All right, so this new unit is all about systems of linear equations, and we're going to end with linear inequalities. So we want to first talk about, well, what is a system of linear equations? Well, it's a fancy way of saying let's look at two or more equations at the same time. So they're going to be your like y equals mx plus b's or your 2x plus 3y equals 7 type equations, but instead of just looking at one, we're going to be looking at two in algebra 1. And when you get to algebra 2, you'll be looking at 3. But a system could have multiple equations, and we need to be able to solve them. And solving a system of linear equations gives us something pretty neat. So um, it's going to be an ordered pair x and y that is true for both equations. Or if we're looking at more than two equations, it'll be for all the equations. And what's neat about this is that's going to become the point of intersection. So if you imagine drawing, for example, two lines, this red one and this light blue one, the point where they meet, that is the solution. So it's the point of intersection. Okay? So what I want you to be able to do with this is I want you to be able to check, and then today we're going to be looking at solving by graphing, and we're going to look at two other methods um, in the upcoming days. So let's first look at how do you check a solution. So we check a solution by seeing is it true for all the equations. So you're basically just going to plug in what you know. So we have 5 comma 1, so that means x equals 5, y equals 1 here. And I just want to check both equations. So I've got x plus y equals 6. Plug in your value. So 5 plus 1 is at 6. That checks, and that's beautiful. Right, remember, if one checks, we're not done. We need to make sure we check both. So I want to check the second equation. 2x minus y equals 9. Okay? So when I do that, I'm going to get 2 times 5 minus 1, and I'll get 10 minus 1, which is indeed 9. So since they both check, it is a solution. Okay? So same deal for B. Just another example here. It doesn't matter how the equations are written, right? Just plug in what you know for x and y based on the ordered pair. So here my x is now -1 and y is -5. Again, just one equation at a time. And if one equation doesn't work, then it's not a solution. So you don't actually have to check both unless the first one you check works out. So I'm going to plug in -5 for y. This is a negative x, so I want to make sure I have the negative on the outside. You can even make that a -1 if you want. And then plug in -1 for x, and then we're going to get -5 equals 1 plus 2, and wait, something's not adding up. This is not true. So if one equation doesn't work, I don't even have to bother with the other one. It's just not a solution. So no, -1, -5 is not a solution. And again, if I want you to explain, you would tell me because it doesn't check for the equation y equals -x plus 2. Okay? So go ahead and try 1 and 2 for your U-try, and let's see what we get. All right, so go ahead and check your work. So I went ahead and showed you my check as well, but we should get no for 1 and yes for 2. So what you want to be careful of here is just the little order of operations, making sure we're careful with those negative x's or negative y's. All right, and then if you have questions, make sure you come back and ask in class. Finally, let's look at our first method for solving. We're going to be solving by graphing. So this gives you a visual which shows you what I was talking about earlier. This is going to be the point of intersection. So what I like to do with these is I like to color code or use colored pens or highlighters just to see my two lines, just so I can check where they are. Because sometimes it's really easy to make an error with graphing your line to start. So I'm going to go ahead and graph this first line, which I'll call line 1, y equals negative x plus 5. So your y equals mx plus b. I'm going to start at the y-intercept 0, 5. My slope is negative 1, which is negative 1 over 1. I'm going to go down 1, right 1. I'm going to do this in blue. So starting at positive 5, down 1, right 1, down 1, right 1. I can also go backwards and go up 1, left 1. Right? And what I want to do is, because I don't know where this point of intersection is going to be, I'm going to make my line span most of the graph. And that way I can hopefully hit one of those will be the intersection points. Okay? So the second one I'm going to call line 2, y equals 2x minus 1. So if any of these was in standard form or point slope form, I can always convert slope intercept form. So forgot to mention that earlier. But let's go ahead and start with our y-intercept, which is 0, negative 1. And my slope is positive 2, or 2 over 1, so up 2, right 1. So again, I want to try to aim to hit the other line, and you'll notice, hey, look, I've got my intersection. So this right here is that point of intersection. So this is going to be the solution. So make sure you don't just point it out on the graph to me, but actually write it down. So give me the ordered pair. So the solution will be this point, 2, 3. So I want to see the answer as an ordered pair, please. And also I want to see your graphs. So don't just leave them as dots, but actually connect the lines and show me the point of intersection. Okay? So that's solving a system. Go ahead and try that. You try problem. And notice for number 4, I'm just scrolling all the way down here, these are in standard form, so get those as y equals mx plus b first, and that'll help you out with the graph. Okay, so go ahead and try 3 and 4, and we'll come back and check your answers. All right, let's first check your lines. Make sure you've graphed them properly, and you should get the solution negative 4, 1. So remember, the more work you can show me, the better it is. So you don't actually have to write what I wrote over here with what I wrote for line 1 and line 2, but on the off chance you got the wrong value somehow for your answer, but I can see that you knew what you were doing, you get more partial credit than if you just threw the lines onto the graph and then gave me the solution. I didn't really know where you might have gone wrong. So again, the more work you show me, the better it'll be. Same thing for number 4. Check and see when you solve for y, did you get those equations? Often that's going to be where the error is if you didn't get the right solution. All right, so double check those equations, your lines, and then we should get our final solution here at 2, 1. Okay, so we'll be practicing this in class. Thank you for listening. Come back with questions.